When evaluating functions, it doesn't really matter what the function is. It could be f of x, g of x, h of x, w of x, q of x, y of x, y of v. The variables really don't matter. What matters is kind of problem by problem what function it's telling you to use and what it's telling you to plug in for that function. For number A here, well, you can see I have three different functions. I have f of x is equal to x squared plus 6. I have g of x is equal to negative 2x. And then obviously I have h of x is equal to 2x plus 9. And so really all that does is it tells me which function is which. So when I get down to A, when it's telling me to find f of negative 3, it's telling me to use my f function, and it's telling me to evaluate it when x equals negative 3. So all I'm going to do is I'm going to take my f function, which is x squared plus 6, and all I've got to do is plug in negative 3 for x. So if I look at it, I would have negative 3 squared plus 6. Negative 3 squared would be negative 3 times negative 3, which gives me a positive 9, plus 6 would give me 15. I get to part B, it's telling me to find g of 5. I'm going to use my g of x function and I'm going to plug in 5. My g of x function is negative 2x, so I'm going to do negative 2 times 5, and I'm going to get a negative 10. So pretty simple there. For part C, I'm going to use 2x plus 9 is my function, and I'm going to plug in a 4 for x. So I would have 2 times 4 plus 9. 2 times 4 is 8, plus 9 is 17. So it's a very simple way there. You can see I'm just plugging in functions. Now, if I get something and I see f of x plus h of x, what that's telling me is I don't have a variable, but I can just plug in what I know. So f of x is x squared plus 6, and h of x is 2x plus 9. And it's telling me to combine those. So now all I do is combine like terms. My x squared, I only have one x squared term. I only have one x term. Then I can combine 6 and 9 and get 15. So it's pretty simple. Now I have g of 3 plus h of 2. So I'm going to plug in 3 for g. So I'm going to have negative 2 times 3. I'm going to add that to h of 2. So 2 times 2 plus 9. Negative 2 times 3 is negative 6 plus 4 plus 9, which will give me a negative positive 3, so that'll give me a 7. Then my last one is f of 3 plus f of 4. F of 3 is going to be 3 squared plus 6. F of 4 is 4 squared plus 6. I'm adding those two, so I would have 9 plus 6 plus 16 plus 6, 22, 28, 37. So it's not overly complicated. You just have to know what function you're using. Am I using f? Am I using g? Am I using h? And then what am I plugging in? Am I plugging in a number, or am I just continuing to use a variable? Now that's if you're given the function and you can plug things in. We can also interpret this stuff by looking directly at the graph of the function. So I've got my function f of x here. What it's telling me to find is the value of my function when x equals 2. So when x equals 2, I want to find what my y value is. So I'll look, my x equals 2 here. I can see it crosses at this point here. And if I erase that mark I made there, I can see it crosses at y equals negative 2. So my value would be -2. For f of 0, when x is 0, you can see y is 0. So my function value is equal to 0. For f of -4, 1, 2, 3, 4, I would have a value here of y equals 2. Now the difference for D and E is it's telling me what my function is. I have to find the x. So it's telling me that my function is 4. I have to find the x. So when is my function equal to 4? 1, 2, 3, 4 would be right up here is the only time that it's equal to 4. And I can see that that corresponds with x equals -2. And then obviously we kind of already covered this one just in an opposite order. When the function is equal to 0, we also know my x equals 0. So we have to understand the difference between when it's looking for a variable, what we're plugging in, or if it's talking about the entire function and what that's equal to.